In this lesson, we are going to cover topic 2.8, also known as transformation of graphs. So, translations mean that you're basically moving the graph from anywhere in your y-axis and the x-axis, however the shape of the graph remains the same. So if you're having an example of x squared, let's say you know that x squared is something like this, however if you move it to the right, it will move something like this, and if you move it downwards, it will look something like this. So let's start. So how can you move your function to left to right? So obviously right now your function is something like this, fx. Why is here an f, you might be wondering. The f right here means that you have a function, meaning that this can be x squared, this can be x to the power of 3, and so on. So let's actually keep on using our example of x squared. So essentially what the new formula says is that if you want to move your graph from left to right, you will have x minus a. So as you can see, you have a new variable here. This is called a. So a is the amount that you move left to right. And if a is positive, you move to right. And if a is negative, you move your function to the left. And something very tricky to always to notice here is that here is a minus, meaning that if you want to move to your right, then in your function you will still have the minus, because plus and minus is equal and not a minus. However, if you want to move to the left, as you can see here, then you will have plus and plus, which will be a positive. So this might sound a little bit strange. I'm gonna put it into perspective as well. So if you have your function, which let's use x squared again. So we have y is equal to x squared, and now we move it. So if we want to move it to the right, then it will be x squared minus 2. Let's say we want to move 2 to the right. You will always use your brackets. And then of course squared as well. So right now it's quite simple. Do you agree with me? I hope you do. And this is minus. You might be wondering that even though it's minus, it's still moving to the right side. However, you're wondering that, oh, minus is negative, shouldn't it be on the negative side? No. This is because you have plus that you have with the formula, and it's together. And therefore you can always remember that if you have x plus 2, that is also squared, then your function will be on the left side, which will be over here. This is a bad graph, but I hope you can understand what I mean. So remember, if you're translating functions, then your final function plus is negative, however negative is plus. So we have now looked how to translate our graphs left and right, but we haven't looked into how to translate them up and down. So if you have your function, let's say that you have y is equal to fx, then, and let's use our example to be x squared, and this is an example, then up and down is, I think, one of the most easiest things in IB. You just plus or minus b. So you have y is equal to fx plus b. Plus b. So what this means is if you have your graph, then depending on what b is, if b is positive, that means that your function will move up. However, if b is negative, then that means your function will go down. I think it's easy as this. So if you have your x squared, then if you have this is your y is equal to x squared, and you have your other example, which is y is equal to x squared plus 5. This is just a random example. Then it will open up upwards. However, if you have an example of x squared minus 3, then it will still open upwards, however, at the point of minus 3. And by now, with all of my lessons and everything that I have talked about, you should also know that the number here, the b in this case, also shows the y-intercept coordinates. So here it's 0 and minus 3. I'm not going to do this one because there's nothing here. And here it's 0 and 5 are the coordinates. So let's look at a translation vector as well. So in many cases in your paper 1 or paper 2, sometimes even paper 3, you will be given something like this. So now you might be wondering, what does this mean? I think it's very simple. This means that you move A to right, you move A to the right or left. And the B means you move your function or your point to up or down. Sorry. So obviously, if A is so let's go over it again. If A is positive, then you move to your right side. And if A is negative, you move to left. And if B is positive, then you will go up, and B being negative, you go down. I think that's very easy. So sometimes in IB you will be given like a function, and with that function you have to be able to get a new function with your translated vector. So let's put it into perspective as well. So you have your function, which in this case today is going to look something like this. And it's said that its points are translated by, why can I not draw? And it's said that its points are relocated with a translation vector of 2 and minus 1. So what does this mean? I hope now that you can lock in and understand. So obviously this means that you will go, I like to draw it out here, you will go 4 to the right, 2 to the right side, and also 1 down. So obviously with this you will get a function, and you can always draw this in your vertex form as well. You will take your function, which is fx minus x plus 3 squared plus 4, and then you will have your other function, which will be fx is equal to x minus 2 minus 1. So you might be wondering, where the hell did this function come from? Well, essentially, if you're translating by a vector, you can turn that vector into a function as well. So you take your 2 and you paste it into this. You might be wondering, here is 2 not negative. Why is it here negative? It's because of the formula. And here you take your -1 and you put it here as well. And then you're supposed to get a new function with this. So obviously what you will do, you will just kind of add the functions all together. So obviously if you have a minus over here, you will keep the minus. And what you want to do is, like, in your head, you want to add them together. So you will get your answer function, or the sum of the 2 functions, to also be negative, because that's the rules. And then, now you might be wondering, here is x plus 3 squared. What this means that in your graph, it's actually somewhere here. It's in the negatives. And here you have 2. So it's actually, you can always just take the 2 numbers, 3 and minus 2. You will get 3 minus 2 is equal to 1. So you will have over here x plus 1. I hope you can get this, because if you take this and you take this, then you get the 1 and you put it here. That's the most simplest way for me to do it. That's how I understand this. And then if you're wondering how can you get the b, you will take your b, which is 4 right here, and you will do 4 minus 1, and you will get 3. So your final answer will look something like this. And sometimes you're also given points. It's given that let's say it's just your maximum point is so yeah, so this is your new graph. When you translate it by a vector, it's just you take the translation vector what you have, you turn it to a function itself, and then you get the new function by adding and subtracting all the spots. So sometimes, I think this is one of the most easiest parts as well, you're given that your maximum point is 3 and 2. So these are the coordinates, obviously x and y, and it's just translated by a vector which is -2 and let's say 6. So I think this is one of the most easiest parts, as you know what you have to do. So obviously you know that it goes 2 to the left and then 6 up. So what you want to do is just take your first, which is, and take this first over here, and you will have 3 minus 2 and 2 plus 6. And about nothing else you need to know about this. And your new m will be 1 and 8. Yeah, there's no more you should know about the translation, except maybe this. You can always go over this as well. So let's talk about vertical stretch as well. So the letter for vertical stretch is P. And let's use an example for vertical stretch, our graph to look something like this. Oh no. Something like this. So it doesn't have to be a good graph, you just have to understand it. So vertical stretch does exactly what the word means. It stretches it vertically. However, it can also shrink it. So vertical stretch, how to actually imply it? Before you used subtraction and maybe you also added something to translate. Now you have to multiply. However, where do you multiply? So you put the p in front, then you put your function, and then you put your x. So this means that you don't put it close to the x, you put it in the first thing that you can put it. Meaning that it's the p, if you have p as 2 is going to be the first number in your function usually. However, let's talk about the values of p as well, as they're quite, I think, not difficult, but a bit tricky to understand. So before, if we had our translation values, we know that the values, when it's negative, it does something. If it's positive, it does something else. However, with vertical stretch, it's a bit more difficult. So you have, let's think of numbers. You have -1 here. I hope everyone knows what is the number line. So you have -1, 0, and 1. So p values, you have two different options. If your p value is smaller than -1, which is obviously over here, or bigger than 1, this means that it will stretch out your p value. It will stretch out your function vertically, meaning that your new function will look something like this. It's not good, but I hope you can understand what I'm trying to convey here. So this will be your new function. However, if your function, the value of p falls between -1 and 1, this means that it will stretch your function, meaning that your function will be more like compressed together. I think that's the way to say it. So obviously your function will look something more like this, much closer to the your x-axis. And that's about it. That's kind of all you have to know. That if it's just between -1 and 1, if it's not, if it's like a decimal number from -1 to 1, then it's obviously going to shrink. If it's bigger than -1, or in this case smaller than -1 or bigger than 1, then you obviously stretch it out. So let's talk about horizontal stretch as well. So let's use the same example. We had our function looking about something like this. So horizontal stretch, I mean, it kind of makes sense. It stretches your function more in, or it can stretch your function more out. So how does the formula actually work? Before you had your letter to be Q, before you had your letter to be P, now your letter is Q. And you use Q a bit more differently as well. And before you wanted to put your P in front of the function, now you put your Q inside the function. And how? You put it directly next to Q. And you will have XQ, or most people like to say QX. But for me, I think the best version to write it is QX. And something also that you always have to know, that if you have your horizontal stretch of Q, let's say it said that do a horizontal stretch by 2, then it will turn out to be 1/2. This is a rule. Sadly, I cannot explain it by heart why it is like this. However, there is something that you always need to know. So let's talk about the formulas as well. So if you have your Q function, let's say that we also talked about the number line. So you have your -1, 1, or 0. Oh my god, 0 and 1. So obviously, but here it's a bit different. If your Q value is between, if let's say your Q value is here, then if before you shrunk it, now you will stretch it out. Meaning that I will draw this in green so you can understand with the graphs. So if your Q is between -1 and 1, and this means that your function will be more spread around, and I think, how can I do this? You will have something like this, essentially longer waves. And the same goes for the other side, that if we talked before that if your Q value is between -1 and 1, then your value will be stretched out. However, if your Q value is over 1 or smaller than -1, that means that your function will be more shrunken together. You will have something that looks like this. Oh my god, it looks like a hot pile of mess, but I hope you can understand that if last time you had it something like this, then now you will have it like this. And always that with all of these three Q values, you will always stretch it by 1 over Q. I hope you can understand. So if even though, let's say that your exercise says that stretch it by a value of Q value of 0.5, then obviously you know that it will be between -1 and 1, meaning that it will stretch out. However, because Q is going to be 1 over Q, and you know that 0.5 is going to be 1 over 0.5, therefore you will always write this in, if you write your function, for example, then you will write it as y is equal to f. Okay, we know that's q as well, and you will be q x. So I hope this can clear up. And the same for every Q value here. If your Q value, let's say Q is 4, then your Q will be like 1 over 4. This is something very tricky. However, you always have to remind this for yourself, and then your F will be like 1 over 4. So it's like reversed in that sense. I think I don't have anything on this page left. So let's look at reflections as well. There are two types of reflections. I think it kind of is very logical to understand this. And so if you have your graph, and let's draw a function to be, let's say our function looks something like this. So obviously there are two types of your graphs as well. So obviously the first one would be the reflection on x-axis, meaning that all the points are the same distance, however just to the other side. And reflection on y-axis would mean something like this. So let's kind of actually understand as well how to calculate them as well. So they're actually very easy. So as I talked before, reflection on the x-axis is this one, and a lot of you know that if you have your function to be, let's say that you have your function of x squared, then negative x squared is your answer for over here. This is actually very simple, meaning that if you have your y is equal to fx, then your new y will be just f, and you put minus in front of everything and you will be fine. It's a bit more tricky on the y-axis, as a lot of you haven't learned this before, and it's not something definitely that you should have learned. So you will have y is equal to fx, this is your normal function. However, what if you want to reflect it on the y-axis and not the x-axis? Then you just put a minus in front f, and you have minus x. So what is the difference? Okay, I hope you're not blind. So the minus is in front of everything else. However, here the minus is here. So you can always remember this. If you want to reflect on the x-axis, minus before everything else. You want to reflect on the y-axis, you put the negative sign right next to x. So composition functions mean that you have your different like translations and transforms together that form one function. So how does it work? So you have your usual function, which is like y is equal to x squared, and then you will have your vertical stretch by 2, then it will be translated by 3 and minus 5, and then you will have horizontal stretch by 3 and then reflected on the x-axis as well. So if you want, you can pause the video so you can do it on your own, and then we can check answers, and if you want, you can do it with me. So vertical stretch by 2, I think this is one of the most obvious parts. So it will be just 2x squared. So sometimes you might be wondering, okay, maybe it's like 2x to the power. No, because then the 2 would go also to the power. So don't do this. I one time messed it up because of this. So and then it will be translated by 3 and minus 5. So you will have your 2x. Then you will have your 2 in front. Now remember, if we want to translate, we also put the minus if we want to translate to the right. And then you square it, and then you put minus 5 as well. Yeah. So horizontal stretch. Horizontal stretch is now something way more different, as I talked before. So obviously horizontal stretch goes straight next to your x. Why can I not undo? Okay. So your new function will be 2. So then you will have 1/3 of your x minus 3 squared minus 5. And then now you remember that you want to reflect it on your x-axis. Therefore you will have just your everything now goes into a big bracket. 2 1/3 x minus 3 squared minus 5, and there's another bracket, and here in front of everything becomes a minus. If it were on the y-axis, then you would multiply the x with minus x. So yeah, that's about it. If you got the same answer, I'm really happy for you. And something I also will mention with composition functions is that if you do them the other way around, usually the function isn't the same. So the order is very important over here. So real life problems, I will do a lesson on periodic functions as well, but you know they usually move something like this. So periodic functions, usually it's about wavelengths and tides, meaning like sea levels basically. You will have your sea level in the morning be higher and in the night lower, and then you have to check what time or what's the sea level every day. And I will definitely do a video on just periodic functions as well, as they're one of the most tricky parts in the IB curriculum. And thank you.